All right, so in this video, we're going to do two things. First, I'm going to show you how to show that triangle sides are congruent when you have triangles on the coordinate plane. Okay, so let's write this out. To show that two sides of a triangle, so a side from one triangle is congruent to the side from another triangle. Okay, here's what you're going to do. Use the distance formula. Let me remind you the distance formula. Distance is equal to the square root of one x value, which we call x2, minus the other x value at the other end of the line, okay, x1 squared, plus the y value of one endpoint, y2, minus the y value of the other endpoint, which we'll call y1 squared. Okay, so this x1, y1 is the endpoint of one of the endpoints of one of the sides, and then x2, y2 is the other endpoint of the same side. This will give you the distance of one side of one of the triangles. Okay, then if you use the distance formula on a side from the other triangle, you'll have two distances. Okay, so we're going to use the distance formula to calculate the length of the segment between two triangle vertices. Now, what is vertices? Vertices is plural for vertex. What's a vertex on a triangle? Well, it's one of the corners. You know, there's three angles. It's triangle. The vertex is the point at one of the angles. So there are three vertices in one triangle. So, and then you're going to do this. You're gonna calculate the length of the segment between two vertices, okay? And you're going to do that on two different triangles. If the distances are equal, then the two sides are congruent. All right, so let's say that we have these two triangles. Let's say they're on the coordinate plane, okay? Like, let's say that this is the y-axis, and this is the x-axis down here, x-axis, and you've got this. Both of these triangles are on the coordinate plane. Okay. Well, what you can do is you can find the length. If this is a vertex right here, here's a vertex. We'll put a point there, and then there's a point down here on the coordinate plane. That's the other vertex. What we'll do is we'll find the distance from here to here, the distance of this side by using the distance formula. Then we'll come down here and we'll have this vertex and this vertex, and we'll find the distance between this. We'll call this one distance 1. We'll call this one distance 2. And if distance 1 is equal to distance 2, then that means that this side of this triangle is congruent to this side of this triangle. Okay? So we use the distance formula for this and for this. Then we would use the distance formula for the medium side. Then we'd use the distance formula for the longer side, and if all three sides are congruent, then we can conclude that the two triangles are congruent. And that's what we're about to do. All right, so here's what we're going to do. We're going to prove triangles on the coordinate plane are congruent, and we're going to use the side theorem. What we're going to do is we're going to show that one pair of sides is congruent, and then another pair of sides is congruent, and the third pair of sides is congruent using the distance formula. Okay, so suppose that we have triangle ABC up here and triangle DEF down here. Okay, now triangle ABC is made up of a segment from A to B, a segment from B to C, and a segment from A to C. And then triangle DEF is made up of a segment from D to E, and a segment from E to F, and a segment from D to F. Now, it's hard to tell which sides are the longest sides and which sides are the shortest sides, okay? Because this side looks very similar in length to this side and very similar in length to this side. But if we use the distance formula, we can get the precise length of each of these sides. So here's the procedure for determining whether these two triangles are congruent, okay? We're going to use the distance formula to calculate the three sides of triangle ABC. And then we're going to list them smallest to largest. Then we're going to use the distance formula to do the same thing for triangle DEF. Then, if the shortest side of triangle ABC is the same measure as the shortest side of triangle DEF, and the same is true for the middle and longest sides, then the triangles are congruent. Okay, so what we need to do now is we need to identify the coordinates of these vertices, the coordinates of A, coordinates of B, coordinates of C. Then we need the coordinates for vertex D, that's this point right here. We need the coordinates of E, which is right here, and the coordinates of F. Okay, we can see here that A is at the point 2, 3. B is at the point -4, 8. And then C is at the point 4, 10. Now D is at the point -3, -1. E is at the point 2, -7. And then F is at the point -5, -9. And now what we need is we need the length of segment AB. So we need the length of segment AB, or the measure of segment AB. We need the measure of segment BC, measure segment BC. And then we need the measure of segment AC, or CA. Either way is fine. I'll call it AC. And then when we have them, we'll organize them shortest, middle, and longest. And then we're going to do the same thing for DE, EF, and DF. Okay, so let's start with AB. Now, I know that this is going to be a good bit of work. We got to do the distance formula 6 times. We got to do it here, 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 and here, and here. But you should get pretty good at this the more you do it. Okay, so if we're going to do the distance of the between A and B, here's what we need. We know the distance formula is going to be the square root of. So here are A and B. We need the two x's, 2 and -4. So we'll do -4 minus 2 squared plus, then we need the y values, 3 and 8. So we'll do 8 minus 3 squared, okay? Now, a lot of this you can just do in your head. -4 minus 2 is -6, and -6 squared is 36. So we'll have the square root of 36 plus 8 minus 3 is 5, and 5 squared is 25. So we need the square root of 36 plus 25. Well, 36 plus 25 is 61. So really, we just need the square root of 61. Now, let me tell you something. You can leave this in this form. It's probably going to make it easier to compare because they're all going to be square roots. So over here, we're just going to write square root of 61. Now let's try the next one. Now we'll do BC. All right, so B and C are these 2 points, -4, 8 and 4, 10. So the distance formula is going to be the square root of two x values, -4 and 4. So let's do -4 minus 4 squared plus two y values, 8 and 10. We'll do 10 minus 8 squared. So that means the distance is going to be the square root of, well, -4 minus 4 is -8. -8 squared is the same thing as 8 squared, which is 64. Plus 10 minus 8, that's 2. 2 squared is 4. So this is the square root of 64 plus 4 is 68. So BC is the square root of 68. I can see right now that BC is longer than AB because BC is the square root of 68 and AB is the square root of 61. So BC is a longer side. Okay. All right, now let's do AC. All right, to do AC, we need the point 23 and the point 410. Okay. So our x values are 2 and 4. So distance is going to be the square root, 2 and 4. We'll do 4 minus 2. That's easier. I just try to put them in the order that's the easiest to subtract. Plus, now we'll do the y values, 3 and 10. We'll do 10 minus 3. 10 minus 3 squared. So distance is the square root of, well, 4 minus 2 is 2, and 2 squared is 4. So it's 4 plus 10 minus 3 is 7. 7 squared is 49. And 4 plus 49 is 53. So this is the square root of 53. So the measure of AC right here, this is the square root of 53. And so you can see this distance is the square root of 53. BC right here is the square root of 68. And AB right here is the square root of 61. So that makes AC is the shorter leg, AB is the medium leg, and BC is the longer leg. Okay, now we're going to do the exact same thing for triangle DEF. All right, so for DE, we have the points D, -3, -1, and E, 2, -7. So for the x's, we have -3 and 2. So the distance is going to be the square root of, we'll do -3 minus 2. Okay, here's our -3, that's an x value. Here's our 2, that's an x value, squared, plus now our y values, -1 and -7. We'll do -7 minus -1, minus -1, and then squared. Now let me remind you that minus negative means plus. So this is going to be -7 plus 1, and then squared. Okay. So the distance is going to be the square root of -3 minus 2 is -5. -5 squared is the same as 5 squared. That's 25. Plus -7 plus 1 is -6. -6 squared is the same as 6 squared, which is 36. Okay. And so this distance is going to be the square root of 25 plus 36, and that is 61. So DE, the measure of DE, is the square root of 61. And look at that. We can already see that that's the same as AB. So we have one side already that is congruent. So DE is the square root of 61. Now let's try EF. All right, E and F are right here. We have 2, 7 and -5, 9. The x values are 2 and -5. So our distance is going to be the square root of, I'll do -5 minus 2. Remember, it's x minus x. Any x, -5 minus the other x, minus 2, squared, plus, then any y, we have -7 and -9. I'll do -7 minus -9 squared. Now remember, -7 minus -9 means plus 9, okay? So distance is going to be the square root of, let's do that again. So -5 minus 2, that's -7. -7 squared is 49. Plus -7 plus 9 is 2, and 2 squared is 4. So plus 4. So here, 49 plus 4 is 53. So we have the square root of 53. So EF is the square root of 53. And look, Look at that. That's the same thing as AC. AC is the same length as EF, which is the square root of 53. 53. Now let's see if DF here, let's see if that's the square root of 68. So -3, -1, and -5, -9. So the distance is going to be the square root of, my x's are -3 minus -5. So that's the same thing as +5, plus, and then my y's are -1 and -9. And I'll do -1 minus -9 squared. Remember, minus -9 means +9. So the distance is the square root of -3 plus 5, because minus -5 is +5, is 2 squared is 4, plus -1 plus 9 is 8. 8 squared is 64, and 64 plus 4 is 68. So we have the square root of 68, which is exactly what we were looking for. That's the same as BC, and so square root of 68. So here's what we have. Longest, middle, shortest. Or we can do it the other way around. Shortest, middle, longest is square root of 53, square root of 61, square root of 68. If we put them in order on DEF, we get the same thing. Square root of 53, square root of 61, square root of 68. Therefore, triangle ABC is congruent to triangle DEF.